Now, I hope you're appreciating that I'm being very careful with my wording here. Immutability only removes security risks attached to the tampering of smart code or its execution. But this is not a comprehensive security guarantee. There are lots of other things that can still go wrong. Immutability does nothing to stop people creating and deploying malicious contracts. Contracts that are designed to do bad things, and which, thanks to immutability, can be guaranteed to reliably and faithfully do those bad things perfectly every single time. Hey everyone, this video is sampled from my online course which teaches you tokenomics for fundraising. You'll learn about the fundraising process, key tokenomic concepts, and get a complete spreadsheet model that you'll learn how to use by solving real-world fundraising problems. You can find the link to the full course in the description section below. And if you'd like to support this channel and help me to create more free content, please like, share, subscribe, and hit that notification bell. That's all. Now back to the video. This looks so similar to what we've seen before, you may imagine that blockchain has similar benefits to offer as well. It gives us the chance to make certain abuses of control impossible to carry out in the first place, and to achieve that without having to rely on any of these external conditions or institutions. To see how this works in the smart contracts case, we'll have to look at some of the details of how smart contract platforms are designed, and that takes us on to the next topic for this lecture. As we look at these design details, bear in mind that not all smart contract platforms have exactly the same features, but the ones I'm going to be discussing here definitely will serve you as an introduction and will give you a relevant point of reference to make comparisons against if you want to do any of your own exploring later. The first feature we're going to look at is known as smart contract immutability. What is this? Well, it starts with the principle that smart contract code can only be used by members of a blockchain network once it has become part of the blockchain. In this context, we say that smart contract code has to be deployed to the blockchain before it can be used. And once that data is part of the blockchain, just as before, it is no longer possible to tamper with the data in that block. And now that includes the smart contract code. Let's take a look at how this works. A deployment transaction first takes the human-readable coding instructions that have been created for the smart contract, and then generates a unique string of bytecode, a set of machine-readable instructions that tells the blockchain software how to interpret the programming that was created by the smart contract developer. This bytecode then gets added to an upcoming transaction block, and once it's part of the next block, is validated by consensus. That smart contract bytecode is then added to the chain and is retrievable using a unique identifying address. Whenever the smart contract is used, it runs using the bytecode retrieved from that specific address. In practical terms, that means that any time this smart contract is used, it can only follow the steps dictated by the code contained in that original smart contract deployment. That smart contract and its code are immutable. Now, I hope you're appreciating that I'm being very careful with my wording here. Immutability only removes security risks attached to the tampering of smart code or its execution. But this is not a comprehensive security guarantee. There are lots of other things that can still go wrong. Immutability does nothing to stop people creating and deploying malicious contracts. Contracts that are designed to do bad things, and which, thanks to immutability, can be guaranteed to reliably and faithfully do those bad things perfectly every single time. Similarly, immutability does nothing to stop the deployment of a badly designed contract that third-party hackers can exploit without having to make any changes to that code. It is really important to understand the specific scope of these security improvements. That is what is going to allow you to make sense of the apparent conflict between the blockchain proponents who talk passionately about improved security and all those news reports that are coming out concerning blockchain hacks and scams. So I guess these limited security improvements don't sound like a great deal so far, but there are more things that we could do to leverage smart contract immutability into something that offers a greater security benefit and that helps reduce some of these remaining bad actor risks. And we can do that by leaving the bad guys with fewer places to hide. That's done by creating strong support for smart contract transparency. Let's see how this works. A typical blockchain allows you to explore the details of all past transactions that have been made. On a smart contract platform, that now includes being able to investigate the bytecode of every smart contract deployment. Now, this bytecode has actually been designed to make it easier to reverse engineer it into human-readable instructions. However, in practice, most developers go one step further and publish that original human-readable code themselves. Because this human-readable code has a unique one-to-one relationship with the bytecode, this allows verification to be done instantly and trustlessly. Let's digest that into a simple summary. Everyone can read the machine code of every smart contract deployed on the blockchain. It is pretty easy to reverse engineer that into readable code. Whenever human readable source code is published by the developer, it can be trustlessly matched to the machine code on the blockchain, and then everyone can read every line of code in the contract, knowing that it matches the bytecode stored at the same smart contract address. Altogether, this means that it's easy to be transparent, and it's really hard to be totally non-transparent. This support makes it possible for anyone with an understanding of code to be able to investigate any smart contract and make sure it isn't doing anything dodgy. But of course, therein lies the problem. Most of us are not developers, and even for those of us who are, chances are we would prefer to be using the smart contracts instead of spending our time having to check them. To make the benefits of transparency broadly accessible and beneficial, we need one more thing to be in place, and that's an auditing service. Expert auditors can take advantage of smart contract transparency to assess the operations and vulnerabilities of smart contracts or even networks of them, and then to publish those results for everyone to see. Now, given that the smart contract code is transparent, this raises the stakes on the auditors to do a good job, since they will otherwise be called out on any obvious errors that they have made. And then, when you take the audit and combine it with this immutability property, that extends the validity of the audit. In fact, some simple smart contracts could remain secure indefinitely. Okay, let's go back to our earlier diagram and update it to include some of the details that we've just been talking about. Yes, blockchains can provide a way to bring trust and security to code which has been developed by unknown third parties, provided that we have smart contracts that are transparent, immutable, and auditable. Unfortunately, all this lands us right back in the middle of some pretty conventional trust issues once again. We need to be able to trust that the auditor has no malicious intentions and that they are competent enough to find flaws or vulnerabilities. Luckily, things have developed now to the point where substantial sums of value are flowing into blockchain development, and smart contract auditing is big business. In this environment, a bad security track record will quickly bring an end to a long-term revenue stream, and there are plenty of competitors lining up to take your place. So for the time being, these off-chain factors are helping to cultivate diligent conduct and competent experience. But even then, honest auditors can still make mistakes. I myself have seen contracts green-lighted by reputable audit firms that were subsequently exploited. So with all this said, we really should take some time to ask, is it worth it? Does this new application development paradigm, one that uses immutable, transparent smart contracts, deliver any substantive security improvements in comparison to traditional application development approaches? Let's take a look.